Humans have always looked up at the stars. We have wondered what lies beyond our world. Are there other planets like Earth? Could we ever live on them? This curiosity is deep within us. It drives us to explore. The night sky is a canvas of infinite possibilities. Each twinkling light could be a distant sun, perhaps with its own family of planets. The dream of finding another home, or making one, is an ancient one. It speaks to our spirit of adventure and our instinct for survival. The idea of transforming other planets is called terraforming. It means making another world Earth-like. Imagine a barren, cold desert planet. Now picture it with blue skies, flowing rivers and green forests. This is the grand vision of terraforming. It's a concept born from science fiction. But now, scientists are seriously considering it. We are learning more about our solar system. We are developing incredible new technologies. Could we truly reshape a planet to support life, to support us? This question is one of the most exciting in science today. Why would we even consider such a monumental task? Earth is our home, a perfect cradle for life, but planets can change. Our own Earth has faced many challenges. Looking outwards gives us options. It could even secure the long-term future of humanity. So what exactly is terraforming? The word itself comes from Latin. Terra means earth and forma means to shape. So terraforming literally means earth shaping. It is the hypothetical process of modifying a planet's atmosphere, temperature, surface topography and ecology. The goal is to make it similar to Earth's environment. This would allow humans and other Earth life to live there without needing extensive life support. It's about creating a new biosphere, a new zone of life on a currently inhospitable world. Several key factors make a planet habitable. First, there's the atmosphere. It needs to have the right gases like oxygen for us to breathe. It also needs to have enough pressure. Too thin and water boils away. Too thick and the pressure could crush us. The atmosphere also acts like a blanket. It traps heat and protects the surface from harmful solar and cosmic radiation. Earth's atmosphere is a complex system, perfectly tuned for life as we know it. Recreating this elsewhere is a colossal challenge. Temperature is another critical factor. Life on Earth thrives in a relatively narrow temperature range. Mars has long captured our imagination. It's our closest planetary neighbour with conditions that, while harsh, are not as extreme as some others. This makes it a prime candidate for terraforming. Today, Mars is a cold desert world. Its average temperature hovers around -63 degrees Celsius. That's far colder than Antarctica. Its atmosphere is very thin, about 100 times thinner than Earth's. It's mostly carbon dioxide with very little oxygen or nitrogen. This thin atmosphere means low air pressure. The low atmospheric pressure on Mars has significant consequences. If you were to stand on Mars without a spacesuit, your bodily fluids would boil. Not because of heat, but because of the lack of pressure. The thin air also means Mars has very little protection from the sun's ultraviolet radiation. And without a global magnetic field like Earth's, cosmic rays also bombard the surface. These conditions make the Martian surface incredibly hostile to unprotected life. So how could we transform Mars into a more Earth-like world? The first major step would be to warm the planet. One idea is to release large amounts of greenhouse gases into the atmosphere. These gases, like carbon dioxide or even more potent artificial ones, would trap more of the sun's heat. This is similar to the greenhouse effect on Earth, but we'd be intentionally enhancing it. We could potentially vaporize the carbon dioxide ice found in Mars's southern polar cap and in its soil. This would thicken the atmosphere and warm the planet. Another approach to warming Mars involves orbital mirrors. Imagine giant lightweight mirrors placed in orbit around Mars. These mirrors would reflect additional sunlight onto the planet's surface, particularly onto the polar ice caps. This focused sunlight could melt the water ice and vaporize the CO2 ice. This would further contribute to thickening the atmosphere and warming the planet. Some have even suggested deliberately crashing ammonia-rich asteroids into Mars. Ammonia is a powerful greenhouse gas, and it would also deliver nitrogen, a key component of Earth's atmosphere. Once Mars starts to warm and its atmosphere thickens, liquid water could begin to flow again. The released water ice would form lakes and shallow seas. Venus, Earth's scorching sibling. Now let's turn our attention to Venus. Often called Earth's sister planet, due to its similar size and mass, Venus is anything but hospitable. It is a vision of a runaway greenhouse effect gone wild. The surface temperature on Venus is a staggering 465 degrees Celsius. That's hot enough to melt lead. This extreme heat is maintained by an incredibly dense atmosphere, about 92 times the pressure of Earth's at sea level. Imagine the pressure nearly a kilometre deep in Earth's oceans. That's what it feels like on the surface of Venus. The Venusian atmosphere is almost entirely carbon dioxide, about 96.5%. This massive blanket of CO2 traps heat incredibly effectively, leading to the extreme temperatures. The Herculean task of terraforming Venus. Transforming Venus into a habitable world would be an undertaking of epic proportions. The primary task is to cool the planet down. One of the most discussed ideas is to reduce the amount of sunlight reaching Venus. This could be achieved by placing a giant solar shade or a series of smaller shades in orbit between Venus and the Sun. This shade would block a significant portion of incoming solar radiation, allowing the planet to gradually radiate its trapped heat into space. This is a colossal engineering project requiring materials that are lightweight yet durable enough to withstand the solar environment. Once cooling begins, the next monumental challenge is dealing with Venus's thick carbon dioxide atmosphere. We need to remove most of it. Timelines and technological leaps. Terraforming either Mars or Venus is not a project for a few years or even a few decades. We are talking about timescales that span centuries, more likely millennia. For Mars, even the initial phase of warming the planet and thickening the atmosphere enough to allow liquid water could take hundreds of years. Establishing a breathable atmosphere with significant oxygen levels through biological processes would likely take many thousands of years. It's a commitment that would need to be passed down through countless generations. The technologies required for such grand endeavours are, in many cases, far beyond our current capabilities. Consider the orbital mirrors for Mars or the solar shades for Venus. A precious anomaly in the cosmos. Exploring the monumental task of terraforming Mars or Venus brings us to a profound realization. It highlights the extraordinary nature of our own planet, Earth. For billions of years, Earth has maintained a delicate balance of conditions. It has a protective atmosphere, abundant liquid water, a stable climate, and a magnetic field. These factors have allowed life to emerge, evolve, and flourish in incredible diversity. Our planet is a vibrant living world, a rare jewel in the vastness of space. It is, as far as we know, unique. The challenges of creating another Earth underscore just how much we take our own planet for granted. The effort, resources and time required to make even a small part of Mars or Venus habitable are almost beyond comprehension. Yet here on Earth these life-sustaining systems operate naturally, a complex interplay of geology, chemistry and biology. Before we turn other planets into Earth, perhaps we should first focus on keeping this one habitable. If you enjoyed this journey into space science, give the video a like, subscribe for more cosmic deep dives, and leave a comment. Which planet would you terraform first? Thank you for watching. See you in the next one.